everyone, my name is Timothy Lee Grant, and in these video lectures of software engineering fundamentals, the goal that I'm having is to identify those concepts which are extremely important for becoming a good software engineer, a good software developer, but I feel I am completely and totally missing. There's a lot of concepts that I have no idea about. I've never even heard of them before, but are vitally important for software engineering. So I went to school, and they always teach you very, like you're just doing your specific homework assignment, and it's very much just get it to work, submit it, you're good to go. But now that I'm talking to a lot of my friends and asking them, like, hey, you're a software engineer, like, what do you actually do? What skill sets do you need? And they'll tell me a whole bunch of things that I've never even heard of, one of which are design patterns. So I am doing in this video series of software engineering fundamentals, I'm doing all of these different design patterns, trying to understand them better. Now, yesterday I was attempting to do open source. I was saying, well, okay, I haven't had much experience with large scale projects before. It's always me just developing it by myself, then turning it in. And now, when I'm at work, I'm a firmware engineer, and it's still me as a team of one developing the project. And so it's not an environment where there's a collaboration or you have to cohesively organize the project in a manner where multiple people can work on it. And so there's a lot of differences between like the embedded systems and actual software engineering. So I decided I know what I'm going to do. I'm going to go and I'm going to get into open source, and this is going to be a wonderful opportunity for me to be able to move forward and become an actual software engineer. But yesterday I got completely tripped up, and I got the code base pulled down from GitHub. I was investigating PyTorch. That was the repo that I was gonna hope to do. So I got the repo down, and then I got all mangled up with virtual environments. I was trying to figure out, like, what is the virtual environment actually doing? How is it working? And oh, I need to minimize myself so you can see that. Anyways, so right here, this is the folder in my Visual Studio. This is where we're going to be investigating the topic of virtual environments. So that's this folder right here. And then, right there, then this is what I was attempting to do yesterday. And you can see I have this like my test PyTorch VENV. This is what kind of tripped me up yesterday. So I I got this, which this was from the actual uh, GitHub. This is what I pulled down. And then I had this script, which I was trying to evoke this PyTorch, and that wasn't working. So then I had to do pip install. And what was I was installing Torch, but I thought this Torch, it was in here. It's somewhere in here, right? It's one of here it is right here. Torch. So I had Torch. And I was like, why won't it recognize that I have Torch? So I had to do pip install, and then it installed in here. And I was like, wait, hold on a second. Doesn't that defeat the entire purpose? So I am very confused about what virtual environments are, how to use them. Are they local? Like, for example, one of the questions that I'm going to ask is from this virtual environments here, which is a separate folder. You saw it. Like, first attempt is here, virtual environments is here. And that's this folder. I mean, virtual environment folder is here. From virtual environment folder, can I instantiate this here test PyTorch VNV? Can I do that? So is it like, how do you actually access them and all of that? All right, so that is the context to this video. That's what we're trying to accomplish today. That's one of the skills that we're trying to fill up. And there's a lot of skills that I feel, man, I really need to hunker down and get good at, and not good at, but just like have a rudimentary understanding. Because when I thought yesterday, I was like, man, I'm gonna go in, I'm gonna get this, I'm gonna do this open source, and I'm gonna be able to move forward and learn so much about software engineering. And then I just got punched in the face, and I was like, I got like, right? So today we're trying to remedy that. So we're not going to have that problem in the future, and we are going to be able to become confident developers, move forward. What was Jeff Bezos's uh, phrase? Step by step, ferociously. There we go. That's what we're going to do. Okay, so I typed this in here. I want to learn about virtual environments. I'm using Python on a Mac. Okay, so let's go. Let's learn about these virtual environments. Okay, perfect. Virtual environments are a crucial part of managing Python projects, especially when you have multiple projects with different dependencies. Here's a comprehensive guide to understand and using virtual environments on your Mac. Okay. What is a virtual environment? A virtual environment is an isolated Python environment that allows you to manage dependencies for different projects separately. So, essentially, what I think the purpose of a virtual environment is, it is if you are trying to develop your project, you have all of these dependencies. So, for example, uh, what's a torch is one dependency, right? Like your project, your script that you're going to be running in Python, it needs to be able to access Torch or NumPy. That's another one. And so you need to install NumPy on normally your local computer. That's how I normally did all of my installations. If I was going to do a project and I said, okay, cool. Here's what I need to do. What libraries do I need to install? And I would say, like, whatever, import this library, import that library, import that library. Then, if I got an error saying, hey, this library wasn't installed, I would do the pip install and then install that specific dependency, right? And then now my Python, here's another question. What does it mean Python understood or Python could get it? Where is this Python? Like, I know that there's something called a Python interpreter. I don't know what it is. I don't know where it is. I don't know how it works. That's another question that I'm going to be trying to uh, understand in this video. So Python interpreter, that's another one. So have some coffee. Anyways, now that's the way that I used to do it. It was just install it, and then I could use my libraries, and we were all happy. But I think what the problem here is that when I do that, it is installed on my local machine, but like a global. So what that means is if I have two separate projects and I'm developing both projects here on my local laptop, if I try to, if one project needs dependencies which are of a certain state, and the other project needs dependencies which are of a different state. So like, for example, NumPy 2. This project needs NumPy 2.3.7, and this project needs NumPy 3.8.2. Well, then there's going to be some kind of conflict because I can only install one on my global local or local machine. And now, what I believe the advantage, the usefulness of these virtual environments is that I'm able to create a virtual environment, whatever that means, right? I can create a virtual environment. Then this virtual environment, I can install dependencies into it. Again, as of right now, I don't know how. Like, I know I think I understand the commands to do so, and we're going to do that in this video, but I don't understand, like, what does that actually mean? When I install into a virtual environment, where is it? Okay. But you're able to install into dependencies into a virtual environment. Then you install all of the required dependencies for project A here in virtual environment A. Then what you can do is install all of the dependencies for project B in virtual environment B. Then you have two separate virtual environments, both with their respective dependencies. I also heard that you're able to then take that information, take those dependencies for virtual environment A, and create from it a requirements.txt. And now this requirements.txt file, you're able to share with other people. So now, on the flip side, once you've done your development, okay, awesome. Now you give it to someone else, and what they're going to do is they're going to go on their local machine. They're going to create their own local or their own virtual environment living on their local machine. So now that's virtual environment C here. And now in virtual environment C, you can put that requirements.txt. Okay. Then what you can do is install everything in this requirements.txt. Boom, it's just one command. It was like pip install -r requirements.c or something like that. And then it boom, installs all of those requirements on where? Virtual environment C. Now, this developer on a separate machine is able to go and develop with all of the associated dependencies. So I think that's kind of where we're going, why we care about them. The question is, like, how do they work? Where does all of this live? How does it get instantiated? Are you able to instantiate it from a far off folder somewhere else? Like, how does it actually work? What is actually going on? So that's the context. Let's keep going. First, let's have a sip of coffee. Let's have another sip of coffee. All right. So, why use virtual environments? Isolation. Each project has its own dependencies, preventing conflicts. Yeah, so that's kind of, you don't want NumPy here and then NumPy here have a conflict, right? If they're living on their own separate virtual environment A and virtual environment B, we're all good. Reproducibility ensures that development environments is consistent across systems. So this brings up a question here. Hold on. If I'm on a Mac computer, which is what I'm on right now, and then, okay, so I have virtual environment A here on my Mac. I create a whole bunch of dependencies and I do things which are Mac. Would that even be true? Mac specific? I don't even know. Okay, my dependencies are specific to Mac. Now, I go and I give that file to myself, but on my desktop computer down there. My desktop computer is Linux. Actually, it's a dual boot. It's Windows and Linux. So, am I able to run those dependent? And then I create a virtual environment on my, let's say, Windows, right? Okay. So now I have virtual environment C. Here's A, here's C. A is on my Mac, C is on my Windows. On my virtual environment C, those dependencies, which were initially for Mac, do they now work on my Windows? Because I'm not doing a, oh come on, what's that called? I forget. Not a virtual environment. It is a virtual. Like, what is VirtualBox? What it? Oh, come on. What is that? What is the name? The name of the thing where you are on one computer but are able to partition a different OS, like VirtualBox, I think it's called, like VirtualBox. What is that called? A virtual machine. Okay, so virtual machine versus virtual environment. Okay, so these things are different. How are they different? I think a virtual machine has a complete and separate operating system. I believe a virtual environment does not. It's simply keeping track of dependencies. The other thing that this kind of throws in is I remember in, like, what was it, Docker, I think, or Kubernetes. I forget what it was, but I remember one of those things. I think it's Docker. You have something very similar to virtual. Like, let me ask that question. So we're going to continue reading this, but I'm right now trying to even figure out the questions that I'm trying to ask in this video. So, I know that there is something with Docker, and I am trying to figure out what the difference is between Docker, virtual environments, and virtual machines. What do we think of that? That was a pretty good question, huh? Okay. And we're also not going to forget that we need to ask, or we need to investigate about this Python interpreter. This shall not escape our gaze. We will figure this one out. All right. So, going back up to here. This is when I was doing LeetCode. This is more LeetCode. Here. All right, let's go. So, ease of use simplifies management of project-specific dependencies. Okay. Setting up a virtual environment on Mac. Install Python. That's already installed. macOS comes with Python installs. Yeah, that's fine. Install virtual environment. I already have that installed. So you would normally do pip install virtual environment. Okay, cool. Now, create a new virtual environment. That's what we're going to do right now. So we're going to come here, go to terminal, new terminal, and then we're going to get rid of this thing, which is taking up too much space. So now what we're going to do is we're just going to follow this. Like, we're currently, I'm going to do pwd. Come on. So we're currently in the folder which we want to create the virtual environment, okay? Now, the question is, can we create one from outside the virtual environment? So this is going to be something interesting. So what I'm going to do is I'm going to do, just as it says, Python 3, and then -m, v, en, v. And now I'm going to do Tim's v, en, v, okay? Press enter. Okay, now look, we got something here. Okay, let's see what's inside. Before we go and continue investigating, we're going to see what's inside of here. So we have bin. What is bin? Activate, activate. So I think that this is probably like a shell, which makes sense because I remember I needed to do source. What was it? Source. Did I do Tim's Tim's v e and v bin? Was it like this? We'll figure that out later, about how to actually activate it. But I remember that it was, I needed to do some command to activate the virtual environment. So I must be running this like shell script here. Okay. Prompt if test. Okay, so activate, what is this? PS PowerShell. Okay. Now pip3. Okay. So that's here in this bin. There's also include, which has nothing. Lib, which has these things. Okay. All right, so far that's what we have. Okay. So I did this. Now I want to activate it. So I need to do, yeah, that's what I thought I did. Oh, I don't think I spelled activate right. There we go. So it did work. I didn't need to like call that script. So now you see here I have this Tim's v e and v. Okay, so now I want to do this deactivate. Okay. I want to see, not that. I want to see if I can go into this like first attempt thing and get this my test. So what if I just did something like this? Like, can I go source and then my test PyTorch venv bin activate? No. So it's not in my current working directory. So I think that I might, let's see, can I do it from like the root? There's not an easy way to get. So what would that be? Like here and practice, right? So can I go my source and now desktop, then practice, then what did I call it? Like open source? Yeah, open source. Okay. Open source. Then first attempt. Okay. First attempt. And now my test, right? My test, bin activate. So can I do this? Let's see. So is I am trying to activate a virtual environment from an outside folder. Can I do this? I am getting an error. Okay. So, yes, you can. However, it is important to ensure that the path to the virtual environment is correct and no typos. So, users source users Timothy desk. Okay, let's just copy and paste this in. See if we can get it. No. Does it not like the space though? Okay. It seems to not like the space in open source and first attempt. Okay. All right. Okay, let's try this. Let's do the double quotes. And there we go. There we go. There we go. Look at that. So, I was able to get I was able to get a virtual environment. So I am now in a virtual environment from an outside folder, but my current working directory is somewhere else. So it's like I'm here, the virtual environment's way over here somewhere else, and I was able to get it. Now I should be able to go and look for all of those dependencies and all of the dependencies which I installed with this. Should we continue up here before we get way too far out of the weed or into the weeds? Yeah, let's go back up here. Let's keep reading, and then we're gonna go and investigate more about like how do you actually check which things are installed? Where are those things? Where are those dependencies actually located? All of that. So we're gonna be looking at that. All right, so we did this, activated, we got that. So now it's telling us to install dependencies. All right, so these dependencies are installed in the virtual environment and won't affect the global Python installation. Very good, very good. There we go. So we can just do pip install and request, and that installs it. Now that we're active in our virtual environment, it will install it to the virtual environment, not here. Then we can do deactivate. Yep, very good. All right, so we did this. NumPy and pandas, there we go. So managing virtual environments. So listing installed packages. This is actually what I wanted to do. Pip list. Pip and then list. Oh my goodness, look at all that fun. Look at that fun right there. So let us investigate like what was there? Ooh, oh, there's a lot, isn't it? Were you expecting that much? Did it scare you? Hopefully not. All right. So, what do we actually have here? Here. Okay, so this is what was tripping me up. So, when I was in my... Okay, where are we? Here. This is first attempt. It means first attempt at my open source. Okay? This PyTorch here is what I got from GitHub. Does that make sense? So I got this and it came here. I did here's where my terminal was, right? Here's my current working directory. I did git clone and then the URL, and it did its thing. Came here, and I have this folder now. Good. Then I created this folder myself, or this file myself. This one is just a normal Python file. And at the very top it says import torch, which if we look here is one of the files right there. So torch exists. Not according to this file though. So I should also say I created a virtual environment. So now I'm working in my virtual environment, which is now I have my test PyTorch v, and v. Okay? And so I tried to do this file, and it said torch doesn't exist. But torch does exist. It's right there in that file. And I was trying to manipulate it, and it just wasn't working. Then from here, in my current working directory, when I had the virtual environment activated, this one right here, what I did was I did pip install torch, or pip install PyTorch. I forget which one I did. And it did blah, 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 blah. It did a whole bunch of stuff. Then, now, I went into the dependencies, and I can't remember if it was here. Was it? I don't know where the dependencies are. That's something that we need to figure out. But I saw torch here, which made me say, wait, hold on a second. The entire point of this open source video was me trying to explore and make changes to this file, because that's the file that is the GitHub clone that I was supposed to be investigating, and I was supposed to be understanding, and then obviously in the future making changes to and pushing those changes up. Now, if I have the PyTorch, if I'm evoking PyTorch, but the import in this file, the import PyTorch, is going in and getting some version of PyTorch which lives here, that's not what I want at all. So that's what my problem was yesterday, and to be honest, I have no idea. Like right now, I have no idea how to fix that. I don't really know. Right, but it opened up the fact that I don't know how virtual environments work, and it said, hey, this is something that's going to cause you some trouble. You need to try to learn more about virtual environments. So that's what we're doing right now. Okay. So here we go. So we see that actually Torch is installed in the virtual environment. So the virtual environment, I think it has to be somewhere in here. That include is empty. Lib, what is lib? Python 3. Does this have torch? YAML. I see pip, which I thought I saw pip here. Pip here. So I might be on the right track. So is this alphabetical? In P R S S S S, one more letter, come on, S T. Okay, so here's torch. So you can see there's two torch folders. I don't want that torch. I don't want this. I want to essentially I want to delete that, because I don't want to be using that torch. I want to be using and evoking this torch. Actually, this torch, right? This one. This is what I want, because this is the one from GitHub. Okay. But that also does show me, okay, so in my environments, lib, that's where the dependencies, I guess, are installed. Lib. Okay. Library. That makes sense. Okay, so we have all that. Cool. Now, here's that command that I was talking about that I'm able to take all of the dependencies, and create a requirements.txt. Let's do that. So remember, oh no, we're in this environment, or we're in this current working directory. So let's do this pip freeze requirements, and I think it's going to take all of these here, and it is going to save it into a file called requirements.txt, and it's going to live here in this current working directory. So let's kind of do that. So right now I have this my test PyTorch v env activated, and I am going to do pip freeze, and then pipe. Is that pipe? Is it a pipe command? I don't know. What's that actually called? But like you're funneling all the data. Where are we funneling it to? Requirements.txt. All right, so here we go. Requirements.txt. So @and parse, and version is 1.6.3. And then, so I think what I can do is I can actually take this file, and from a separate virtual environment, I can go and install all of those these dependencies. Okay. Pip install requirements. Yeah, so that's how you actually install the requirements here. So pip install from a file, and then what file? Requirements.txt. Awesome. Now, the other question that we were asking, what is the name of the thing where you are on one computer but able to partition a different operating system, like VirtualBox? Okay, not a very well formulated question, but luckily Copilot understood what I am trying to say. Okay, the concept you're referring to is called a virtual machine. Virtual machines allow you to run multiple operating systems on a single physical computer by creating isolated environments for each operating system. Isolated environments, okay. Virtual environments, isolated environments. Okay. These environments act as if they are separate physical computers. So that's what I was meaning by I think virtual environments have their own operating system. Every virtual environment has either Linux or Mac OS or Windows or some other OS, and it is a full dedicated computer. It thinks it is the full deal. To its knowledge, it is the full deal. Okay. Virtual machines. A software emulation of a physical computer that runs an operating system and applications. So you can run applications on the virtual machine. Great. Virtualization, the process of creating virtual versions of something, such as hardware platforms, storage devices, and network resources. Okay? Hypervisor, a software layer that creates and runs virtual machines. They are two type. Type 1, bare metal, runs directly on physical hardware. Okay? VMware. Then type 2 is hosted, runs on a hosted operating system. Okay. I think what this means is maybe bare metal means that it's actually partitioning real physical like memory, for example, real physical CPU resources. Whereas this hosted, I think what this is referring to is like here on my Mac OS has ultimate control over all of the resources on my computer. It has resources to the all of the CPUs, all of the I don't have GPUs, but if I did, GPUs, all of the memory, all of the disk, the networking ports. It has access to all of that. It also determines time slicing, so how much one application gets of each of those resources, it determines everything. Now, on my Mac, if I were to get a VirtualBox, this VirtualBox is essentially an application that my Mac OS is going to look at and give it certain uh, allocation of those resources. Allocation, it's going to, so the VirtualBox is going to be running, let's just say Linux. And Linux, that OS on the VirtualBox is going to make requests to my computer, which is the Mac OS, and say, hey, I need to get to this port. And the Mac OS is going to take that request and actually complete the request, right? So I think type 1 is more of the virtual environment, not virtual environment, virtual machine has access to actual hardware resources like the CPU and all of the memory. Whereas type 2, I believe from this description, I don't know this to be completely accurate, but at least the way I'm reading it is that the virtual machine is on top of your OS, and your OS ultimately decides what resources to give it, how to allocate things, and how to do that. Okay. Examples of virtual machine software. VirtualBox is an open source hypervisor for running virtual machines. VMware, a commercial product for running VMs on a desktop. So I've heard of VMware, but I don't think I've actually used it. Okay. Hyper-V, a native hypervisor provided by Microsoft for Windows. Okay. QEMU. Oh no, I hate QEMU. I hate QEMU so much. In my OS class, we had to use QEMU. Oh my goodness, I have such bad memories of my operating systems class. I hated that. Me and Susie took our OS classes 1 and 2 together. OS 1 was good. We had no problem. We got to OS 2. That class, oh my goodness, was so difficult. Both me and her said, I am so glad we never need to touch any of that low level uh, software, embedded systems kind of stuff ever again. We are done with it. Then I get a job, walk into my job the very first day. I get down onto my screen, and guess what I see? Embedded C. Oh no! Embedded systems. So that's what I am right now. I'm an embedded systems engineer. I work with the physical hardware, like the actual hardware components, how they're laid. Not, I don't do the layout, but I have to check the schematics, see what my microcontroller is connected to, how I'm able to interface with them, what communication protocols they use, stuff like that. So that's what my job is now. And it was kind of funny because when I was in school, I was like, thank goodness I never need to do a low level software ever again. I never need to worry about firmware. I never need to do any of that. And then I get to my work and I'm like, oh, Well, I guess I'm a firmware engineer now. I told Susie that the first day. I was like, guess what this is? Firmware. And she was like, oof. But it's fine. Um, Now I am just recalling it because of that QEMU. We had to use the QEMU for OS, our OS2 class. And let me just say, I am scarred by that. I was like, I just saw that word. I'm like, no, please, no, I don't want to touch this. Do not want to touch QEMU. What is it? It is an open source machine emulator and virtualizer. So I guess that makes sense because in my OS2 class, what we were trying to do is we were building our own operating system. And so I think what QEMU did is it acted as the hardware for our software, which the software was the operating system. So the operating system needed uh, hardware to run, right? It needed certain memory and stuff like that. And so we had a whole bunch of C files, right? Which were the operating system, and we were using JOS. That's what JOS. I forget what it stands for, but J and then operating system. So that operating system would run on the QEMU like environment, which was the QEMU, like we were emulating some specific uh computers, like some hardware computer. I think if I actually did go back and looked at that project, the OS2 project, I think now I would be able to get it a lot better than what I have than when I initially did it. I remember when I was in the OS2 class, it was like I was really struggling. I was spending all of my time on that class, and I just was like pouring all of my energy into it, and I was still not getting it. It was so difficult. But I think, there was a lot of different problems, like, and that's something that with these series I'm also trying to mitigate is what I noticed in software engineering and I guess engineering in general is if you have it's easy to fill up a little hole. But if you have a whole bunch of little holes in your knowledge and you try to do a project, you just get like boom, and then you just can't do it, right? I think that that's what was going on when I was doing my OS2 class is there was so many things that I was missing, so many things that I didn't understand. And so when I was going and trying to do my projects, I was running into too many things. And normally if it's like one thing that you don't understand, you just go and you get it, right? Like okay, I don't understand this. You go understand it and then you're back. But in my case, I'll give you an example. The functions would say uh, void star, and then I can just write it. Like it would be like this, like example.c. Okay. It would be like void void star and then function and then args1 whatever int args1 int args2 like this, right? And then return, and then whatever, it would have a return. And I'm purposefully doing this right here, right there. So I saw this void right here, and I said, oh, it's void, so it doesn't return anything. Why is it returning something here? And that threw me. And then later on in other files, or in other C files, they would make calls to this funct right here, and it would grab something, right? It would grab the return value and then do operations with it. And I was like, but there's a void function. I was, a lot of you are going to be looking at this video, be like, how did you get confused by this? But let me just say, like, the answer. This doesn't mean void, like it doesn't return. Like, this means the function doesn't return anything. This means it does return something. It returns a pointer. But this pointer is an unspecified type. It could be any type of pointer. So, like, you can do whatever, int pointer, and then my PTR like this, and then you can do return. What are you returning? My PRT. I guess I spelled it wrong. Like that. So it returns a pointer, but it could be an int, or it could be a float. And both of those are valid. So it's like that was one example. Like, I didn't understand that. That threw me. Then we get to this QEMU thing. And what is QEMU doing? I have no idea. And then it was my first time ever using GitHub. So how do you pull down from this cloud? Like, what is going on? I don't know. And then how do you make changes and then push it back up? And then I kept getting all of these merge conflicts, and I didn't know what a merge conflict was. And so there was like so many things on top of the fact that the actual class was really difficult and the actual concepts were difficult. And furthermore, this was one of the only classes where I had to deal with more than one file. Because most of my classes, you just have one singular file. It's a big file. And it just does whatever you need to do, right? Like, it accomplishes your homework assignment. Once it accomplishes your homework assignment, you send it in, you get your good grade, and you are golden. But in this class, all of a sudden, I had 5,000 different files. How do they interact? I had never seen that before. So that was another thing. So there was like 5 things going on top of the actual class was difficult, and the concepts in the class were difficult. And so I think that's why I really was struggling in that class. Now I'm kind of curious, like, if I went back now, would I be able to do it? Like, would it be a lot easier because I have filled in some of those gaps. I would hope so. But that's kind of what I'm hoping to do with these software engineering fundamentals video, is find those gaps in my knowledge, try to figure out what I don't understand, all of those different skills and technologies and concepts in software engineering that are potential landmines for me when I'm trying to develop a project, because I don't want to get tripped up on it while I'm doing a project and then all of a sudden I can't complete my project. See? So anyways, QEMU. That was a very long tangent, but this was a very intense emotional trigger. Okay, so benefits of virtual machines. Isolation. Each virtual machine is isolated from the others, ensuring that an issue in one VM doesn't affect another one. Okay, so if you break one, you can just move on to another. But that's virtual machines. That's not virtual environments. Portability, virtual machines can easily move from one physical machine to another. And that kind of makes sense because the OS is the same. It's still Linux. You're just taking Linux and putting it. Linux is on a Mac. Okay, great. Then you take your Linux, it's still Linux, and then you put it on a Mac or Windows. Well, it's still Linux here, so it's able to be ported. And that's one of my questions that I have about virtual environments. Like, does that work? Okay. Resource efficiency. VMs can share the physical resources of a single machine, flexibility, run different operating systems. Awesome. Okay, so now the question is, I know that there's something called Docker. I'm trying to figure out what the difference is between Docker, virtual environments, and virtual machines. Do I have any coffee left? Not much. And we're out. Okay, so Docker. What is it? Docker is a platform that enables you to develop, ship, and run applications inside of lightweight containers. Okay, so with Docker, we have containers. Now, that's what we're going to try to figure out. Like, what is the difference between this container and the virtual environments and the virtual machines? Yeah, so those are the three. Containers, virtual environments, virtual machines. Docker is I already read that. Containers. Containers package an application and its dependency into a single unit that can run reliably across different computing environments. Okay? Containers share the host operating system's kernel but run isolated user spaces. Okay. What is a user space? I'm not quite sure there. Okay. Use case. Okay. Ideal for microservice architecture. Microservice. This is another one that I've heard is very important, but I don't know much about. Okay. So, ensuring consistent environments across development, testing, and production. Good. Performance. Generally more efficient and faster than virtual machines because they use the host OS and do not require full OS installation. Cool. Virtual environments. A virtual environment in Python is an isolated environment that allows you to manage dependencies for several different projects. Tools like V&V. Okay, isolation. Only isolates the Python interpreter, and we have not forgotten about that. We're still going to figure out what this Python interpreter is and its packages, not the entire operating system. So, best for managing Python dependencies and ensuring that different projects do not interfere with each other's Python packages. So it's very lightweight since it only involves Python environment. Okay, so virtual environments, I guess, are only to do with Python? Is that real? Virtual machines. So we kind of went over what the virtual machine is. We can skip that. Okay, so differences. Isolation level. Docker is application level isolation using containers. So this has full OS isolation. Trying to figure out what that even means. Resource usage. Docker uses the host kernel. Virtual environments. It's not even dealing with that. So it's only dealing with the Python interpreter. That's it. And the associated dependencies. Okay, so I think I see why. I think I see what's going on. So these virtual environments is I'm not doing anything to change my hardware. I'm not doing anything to partition my hardware. I'm not doing anything to set up an actual like real separate environment. It is simply that I am changing the settings of my Python interpreter and the dependencies which are or are not installed. That's it. Okay. So practical uses. Okay, CI/CD pipelines. That's another thing that I need to do in my software engineering fundamentals. So I need to learn microservices. I need to do CI/CD pipelines. I have a lot of skills that I need to be moving forward in. So there's a lot on the horizon. Okay. Now, virtual environments, Python deployment, managing specific. I think we get this. And then this was what we've already done. Cool. So now, what do I want to do? Python interpreter. Okay. What is the Python interpreter? And where does it live? Also, where do the dependencies in my virtual environment live? How does the interaction between the virtual environment and the Python interpreter actually work? Okay. Really wish I had more coffee. There's nothing in there. Nothing in there. Still, can you see it? There's like a little. There's one more sip. Not really. It's not a sip, but okay. Python interpreter. What is it? The Python interpreter is the program that reads and executes Python code. Okay. It reads and executes Python code. Okay, so I have a file. This file is a Python file. The Python interpreter, whatever it is, wherever it is, whoever it is, will read this and execute that. Where it lives. The Python interpreter is usually installed in a specific directory on your system. For example, users local bin Python 3. So, or in bin of your virtual environment. Okay, so let's check that. Let's go to here, bin Python 3. Python? I didn't want to do that. Whoops. Is this where it lives? Bin lib. I mean, there has to be, I'm guessing Python, they're a binary. So I thought that it would be like, oh, and now all of a sudden I'm no longer in my other virtual environment. I'm in this virtual environment. But anyways, so I was assuming that I would be able to see a lot of C code for my virtual, or for Python. I'm guessing that Python is running in C, right? So I don't really know how that's working. When you install Python, it places the interpreter and associated files in directories. Okay. So, um, when you create a virtual environment, it creates an isolated directory structure that includes its own Python interpreter and libraries. So, the dependencies are installed in the lib. Yeah, we see that, right? Okay. Interaction between virtual environment and Python. But I also want to know, like, how does Python actually even work? But maybe that's actually more of like a compiler's question. Like, how does, like, on that, the question that I just asked, that's more of like, how do you write your own language? Might be an interesting question, but I don't know if that's part of the scope of this video. Okay, so interaction between virtual environment and Python interpreter. When isolation. When you activate a virtual environment, it modifies your shell's environment variables. So I've heard about this. Environment variables. Shell environment variables. That's like, what are shell environment variables? But I don't want to do that. I want to keep reading. So I'll let it think, and then we're going to go back to that. All right. So, that the virtual environment interpreter is used instead of the global one. This ensures Python commands you run use the isolated interpreter and packages. Okay? Activation. Activation of virtual environments changes the path environment variable to point to Ben. Okay, so I guess instead of using your normal path environment variables, you're now using the environment variables which are in that specific virtual environment's folder location. So you're just pointing it to a different location. So using the isolated interpreter, once activated, any Python or pip command, so it's just, again, like these virtual environments are just interacting with Python and pip and all of those like dependencies. So it's nothing to do with my OS. It's nothing to do with an actual environment. Okay. So this means any package you install or use will be isolated to the environment and won't affect your global Python installation. You can deactivate it here. Okay. So what are shell environments? Oh my goodness, there's a lot of stuff here. Okay. Shell environment variables are dynamic values that can affect the behavior of processes and applications running in your environment. I think I'm going to have to take a few seconds to. All right. Okay. So, shell environment variables are dynamic values that can affect the behavior of processes and applications running in your shell environment. These variables are set and used by the operating system and shell to pass information and control how commands execute. It might be that I'm getting kind of tired, but honestly, I didn't really understand that paragraph. I think my brain might be I noticed that when I do these videos, I can go for about an hour, and then unfortunately, I don't have a timer to tell me how long I've been recording, but I'm guessing that it's about an hour right now because my brain is starting to. I can feel it. Like I'll have to take a little bit of a break soon. Okay. Key concepts of environment variables. Environment variables. They are key value pairs stored in the environment of the shell session. Examples include path, home, user, shell, etc. So the purpose: provide configuration settings for the shell, configuration settings for the shell. Okay. Provide configuration settings for the shell. Store information such as directory, user details, and command paths. Scope. Environment variables can have global scope available for all processes or local scope specific to current shell session. Okay? Common environment variables. Path. A list of directories where the shell looks for executable commands. Okay, so this just must mean that I have access to certain commands, like for example, pip, I think. Pip install or Python, right? I can evoke Python by just doing like here, Python, right? And so that Python is a command. And now when I did Python here, normally it would look in my path for the actual command, which is Python. But because I'm in my virtual environment, it's not looking there. It's actually looking where? Like here, I think. And then doing this Python, right? And I think I can also do Python 3. So let me exit. Okay. And then Python 3. I should be able to do that. Yeah. So I'm accessing this Python 3, not the other Python 3, which is on my local computer somewhere in here, right? So let me exit out of here. Exit. Okay. So pip list. I want to see what I have here on this Tim's virtual environment. That's the one that we just created, right? So here I have pip and setup tools. Okay, cool. All right. So user is the current logged in user name. Okay, so that's just like who I am. Shell, the path that to the user's default shell. Okay. I know shell is an important concept within low level software. I haven't dealt much with shell, so I don't really exactly know what it is, but how to view virtual environments. So print. I'm curious what's going to happen when I do print env environment variables, but I do it inside of this virtual environment. So I'm going to do that. So print env. Okay. Ooh. Okay. There we go. Virtual environment prompt is here. VS Code injection, my name, all of this. Virtual environments. VS Code get ask pass main. Okay. Args. Okay. All right. So how to set virtual environments. You can set virtual environments using export command. variable name value, variable, okay. So I can use this echo, which is like a bash command, to access variables of a okay. Going in and editing the bash RC file. I remember doing that in one of my classes. I can't remember how. I remember that changes. You're able to change like the color of your command prompt, and you're able to change settings, but I can't remember exactly how. I remember going into the bash RC file, but that was a long time ago. All right, so I guess we've kind of completed this video. I wanted to understand virtual environments. I think I understand them significantly more, and I got to the point where I can kind of make progress. And if I come into contact with a virtual environment in the future, it will not hinder me from understanding it, and it will not stop me from completing my project, which is the entire point of the video that I have this video. So essentially, virtual environments are uh, there's a folder that's created that points my Python interpreter and all of those the Python interpreter and pip to this specific folder, and it uses this Python and this dependency instead of the one on my local global machine. It just uses this specific one. And then when I install something, it installs it into this specific local one, and then I can export it out. So that's the main idea. I think this video I am going to classify as a success. I think we learned a lot, and I think this video was a productive one. So thank you guys so much for watching this video. I am going to take a little bit of a rest, probably get more coffee, and fill this one up with some water. And I am going to be back. I don't know what video I'm going to make in the following hour or whatever, but I'm going to make another video. I hope you guys enjoyed this one. If you did, subscribe. That would be amazing. Thank you guys for watching. My name is Timothy Lee Grant, and I will see you guys very soon.